Scientists just made mice see-through using food dye, and humans are next. Of course, this is just an image by the foundation. This is just for illustration purposes only. Technique has not been applied in humans yet. A common food dye can turn the skin of living mice transparent, but we don't know if it'll work on humans. The common food dye can turn the skin of living mice transparent, enabling researchers to peer inside the body without surgery. This is the first time scientists have used the technique to visualize the tissue of living mice under the microscope. They use a food-safe dye, which can likely be found in snacks in your pantry, and several fundamental physics principles to render the mice see-through. Biological tissue is chock full of stuff, from proteins to fats and liquids, and each substance differs in its ability to bend or refract light that hits it. This property is referred to as a material's refractive index. If light particles hit a boundary between two materials with different refractive indices, those particles are forced to change direction or scatter. And while light can easily pass straight through transparent materials like the glass of water, opaque materials get in the light's way, sending it bouncing in many directions, and that light then bounces to your eyeballs when you look at the material, and thus the brain interprets that scattered light as coming from an opaque object, and that's why you normally can't see through somebody's body. But now scientists discovered a simple trick to change the skin's transparency. They took a concentrated food dye that's great at absorbing light, dissolving it in water, and then applied the solution to the skin, which balanced out the refractive indices of substances within the tissue, making it temporarily translucent. Can you imagine? The researchers described this approach in a new study published Thursday, September 5th in the journal Science, that's today. They tested the technique on rodents using a U.S. Food and Drug Administration certified color additive called tartarzine, also known as FD&C yellow number 5. This yellow-orange dye is often added to foods such as desserts and candy, as well as various drinks, drugs, and cosmetics. After initial experiments showed that tartrazine could turn slices of chicken breast transparent, the team turned to lab mice. They rubbed a tartrazine solution onto the rodent scalps and then observed the animals under a microscope. It takes a few minutes for the transparency to appear. Study lead author SeeThrough, an assistant professor of physics at the University of Texas at Dallas, said in a statement, "It's similar to the way facial cream or mask works. The time needed depends on how fast the molecules diffuse into the skin." And once the solution is set in, the researchers were able to see blood vessels streaming across the surface of the mice's skulls at a micrometer level of 0.001 millimeters resolution. In a separate experiment, they applied the tartrazine solution to the mice's abdomens. Within minutes, they could clearly identify organs such as the liver, small intestine, and bladder. They could even see muscles within the gut contracting, as well as subtle motions of the abdomen caused by breathing and the heart beating. The transparency could be revealed by rinsing the mice's skin with water, ridding them of the food dye solution. Any excess tartrazine that was absorbed into the body was excreted in the rodent's urine within 48 hours of application. The treatment induced minimal inflammation in the short term, the researchers wrote in the study, but it did not appear to have any long-term effects on the animal's health, as measured by changes in their body weight and blood test results. This approach offers a new means of visualizing the structure of activity of deep tissues and organs in vivo, in the living body that is, in a safe, temporary, and non-invasive manner. Christopher Rowlands and John Gorecki at Imperial College London wrote in a commentary of the new study. Neither Rowlands, a bioengineer, nor Gorecki, a physicist, was involved in the new work. The new technique has not been tested in humans yet. Our skin is about 4 times thicker than that of mice, which would make it harder for tartrazine to be absorbed into the deepest layer. But if future studies show that the dye works in humans and it is safe, it could become a useful medical tool, the research team says. Looking forward, this technology could make veins more visible for the drawing of blood, make laser-based tattoo removal more straightforward, or assist in the early detection of treatment of cancer. Study co-author Gu Song Hong, assistant professor of materials science and engineering at Stanford University, said in a statement. And this is by Emily Cook on Life Science. Please leave your comments. Thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.